Hi everyone, today we are going to derive the bending equation of a beam or beam like a structure and how the question is asked generally derive the bending equation stating all the assumptions made. So today I'm not going to tell you anything about this assumption because you can easily find it in a book. I would prefer engineer Raj book. It is good book. Actually I follow the same book most of the time. So now let's come to the derivation. It's a simple derivation. It's quite easy if we understand the basics principle of this equation. It becomes easy. So there is a beam. This is a beam, and this is a transverse section of the beam, and this is a longitudinal section of the beam. So this beam is when no load is applied on the beam. So just suppose there are so many layers in this beam, so when the load is applied or when the load is transferred on the beam from the slab, the beam occur in this shape, in a curve shape, where this portion has compressive force and this portion has a tensile force. And since there are so many layers inside this beam, so when we move from this surface to this surface, the compression force decreases and tension force increases, and there is certain layer between this one particular layer between this beam, or let's say point where there is no strain or there is no stress, and because there is no stress there is no strain, or we can say that there is no tension and no compression, which is called neutral axis and which is denoted by the red line in this figure. Now let's suppose this is one layer RS and this is PQ layer, which is a neutral layer or neutral axis, a layer of neutral axis. So when the load is applied, this PQ become P dash and Q dash, and RS become RS, R dash and S dash. But there is no stress in the neutral axis, so this PQ and PQ dash, PQ and P dash Q dash are same because there is no strain in the neutral axis, and this RS is equal to PQ because initially this is one section, and this all section the layer are of equal length. Before the load applied, the RS is equal to PQ. After the load is applied, RS become RS, R dash, S dash, PQ become P dash, Q dash. So in the neutral axis or in this section there is no strain. In this section there is no strain, but in this section, RS section, there is a strain, and the distance between these two layers is let y. So strain in RS, strain in RS is equal to RS minus RS R dash S dash by RS. But we know RS is equal to PQ is equal to P dash Q dash. Therefore strain is equal to P dash Q dash minus R dash S dash by RS. Again, just write this equation and leave it. Now again we know, see this is the radius of curvature when load is applied, and the angle subtended by these layers are alpha. So P dash and Q dash is equal to, see P dash and Q dash is equal to r times alpha. This is a basic formula that we have studied in mathematics. R into alpha. Similarly, this r dash and r dash is equal to r minus y times alpha, because this r dash and r dash and the distance from this layer to here is this total r and this minus y, that is this distance is r minus y times alpha. Now simply substitute this two value in above equations, that is strain is equal to pq you can write r alpha and r dash you can write r minus y times alpha by r alpha, or which will give final result as y minus r. Now if the stress in areas is sigma and Young modulus is A, then we know. What we know is when the stress is given as a sigma and the modulus of elasticity is A, then strain is also given as STR, and strain is also given by stress by Young modulus of elasticity. See, one strain from the figure we got the strain as y by r, y upon r, and from formula, for the basic formula of a strain we got stress by E, elasticity, Young modulus of elasticity. So since both are the strain, we can write as E sigma E by y by r. This is one equation of this derivation, but it is not finished yet. Now here we have considered this as a longitudinal section. Now let us consider a transverse section. Let's draw the transverse section. This my drawing are not so good. I'm very bad at drawing actually. Please don't mind it. This is a strip of area dA, and distance between this and this is y. So the normal force acting on this strip having a dA is given by E by r times y dA. Now you might be wondering how we got this. Simply we know stress is equal to force by area, or force is equal to stress into area, and stress from here stress what we got stress E by r times y, and A is as dA. From here we got this neutral force as this. Now this is distance and a neutral force is acting on this strip, so it will create a moment of this force is given by force time distance and y, that is E by r times y square dA, and this is a moment given by the normal force acting on this strip, and this moment is a resisting moment when the load is applied, and which get moment, and this is a resisting moment to resist that moment, and this is what we need to calculate and what we were calculating. Again we know that y square dA is second moment of inertia. Therefore this moment become E by this actual moment E by r time if I